All right, here we are for our lesson number 3. We're just trekking right along, aren't we? Here we go. So lesson number 3 is on subtracting mixed numbers. This is what we were kind of just mastering as you guys left, but I know a few of us were still working on that borrowing idea and just remembering all those steps. So if you haven't already, we had an anchor chart in our room, but we can go ahead and make an anchor chart right here to the side. So I'm going to go ahead and start us off. What is our first step if our denominators are not the same? Yep, you're going to make an equivalent fraction. With a like denominator. All right, so now you're going to look, you have your equivalent fraction, but the number that you're subtracting might be bigger, might have a bigger numerator than the number you're subtracting from. So just like with whole numbers, we're going to borrow from our whole number. And that's only if you need to. And after you borrow from that whole number, where is it going to go? Just like if you borrowed a cup of sugar from a neighbor, it's going to the fractions. So you're going to add the whole to your fraction. And this is going to make a unique fraction. What do we call a unique fraction when the numerator is greater than the denominator? What do we call that? If you said improper fraction, you are right. All right, now we can just do what we would normally know to do. We're going to subtract the whole number and the fraction. And then finally, you're going to have to reduce or simplify. And there's a couple of different things you're going to have to do. One, if you have an improper fraction, you have to pull out the whole. And you're going to give it or add it to your whole number. Your last one is you're going to look at your numerator and your denominator of your final fraction, and you're going to see if you need to divide it to reduce it, and you're going to use those magic numbers 2, 3, 5, 7, 11, and 13. All right, if you're struggling with this concept still, which is absolutely fine, remember we said this is pretty much the hardest part of fractions. If you're struggling with this skill, go ahead and stop and make a little piece of paper or take an extra screenshot of this where you have it to work from, just like we have it up on our board in school. So we use our anchor charts to help us in the classroom, and there's no reason for you not to use it at home. All right, so we're going to follow the same model. We're going to start with 1 and 2, and then I'm going to ask you, if you haven't already done these, to pause the video, and then you're going to, actually, I'm taking a look real quick, so I'm not seeing one that needs to be borrowed. I'm going through and seeing if I can find one that needs to be borrowed. There may be no borrowing on this sheet, which is fine. We can practice some of those on another day. Nope, there's not going to be any borrowing on the sheet. So this is just going to be your standard subtraction, pulling out wholes if you need to, and reducing. So that's good. If we need to practice, and I'll make a note of that we can practice some where we borrow as well. I'll find some problems. All right, here we go. We need common denominators, and I'm assuming now you've had so much practice with these, you're not writing out all the steps. You're kind of making little notations like I am. So I'm just going to make my equivalent fraction to the side. 5 times 4 is 20. 4 times 4 is 16. 4 times 5 is 20. 1 times 5 is 5. So I have my two equivalent fractions with like denominators of 20. Now we're going to go to our regular old math. 9 minus 2 is 7. 16 minus 5 is 11 twentieths. 2, 3, 5, 7, 11, 13. They're not both even, not divided by 3, no 5s, no 7s, no 11s, can't divide top by bottom, done. Again, I know I practice that, I do that every single time we reduce, and I hope that whenever you're now getting the habit of just doing that same procedure, is looking at your prime numbers and going through all the steps. And remember, that last question is, can the numerator go into the denominator? Can the denominator be divided by the numerator? That's your last check. All right, 15ths. Remember, often it is the denominators multiplied, but not always. 3 times 5 is 15, 2 times 5 is 10, 5 times 3 is 15, 1 times 3 is 3. Now I have my equivalent fractions, so I'm going to focus on those and ignore the other fraction. 7 minus 2 is 5, 10 minus 3 is 7, and we are talking about 15ths. Can I divide by 2, 3, 5, 7? Can I divide the numerator by the top? No. Done. All right, at this point, if you haven't completed this assignment, you're going to stop and practice 3 and 4 on your own, and then you're going to start your video again to check. If you have completed, you're going to go ahead and check the next 2. And as I've stated in each video, if you've finished this assignment already, if you take a screenshot and show me that you've completed it, I'd be happy to do the problems and to take a picture of it. And also, if you're having any problems, you can chat with me on Dojo. I think we're going to try to set up some video capabilities, so we'll get that going. You can also call me. I'm going to put my number up here. Your parents all have it, but you are welcome to call me, and we can work through any problems as well. So go ahead and write down, if you haven't written down, my cell phone number. All right, I'm going to do these real quick. Here we go. We need twelfths for common denominators. 3 times 4 is 12. 2 times 4 is 8. 4 times 3 is 12. 1 times 3 is 3. Hold on, Simone. I'll let you in a minute. 6 minus 4 is 2. 8 minus 3 is 5. And we're talking about twelfths. Can't divide by 2. Can't divide by 3. Girls, settle down. Can't divide by 5. Can't divide numerator by denominator. Done. All right. 6 times 3 is, 2 times 3 is 6. So we're going to use 6. 2 times 3 is 6, 1 times 3 is 3, 3 times 2 is 6, 1 times 2 is 2. All right, so now I'm just going to focus on my equivalent fractions. 6 minus 3 is 3, 3, 6 minus 2, 6 is 1, 6. I know that 1 obviously can't go any smaller, so it doesn't really matter what this number is on the bottom. It could be a billion for all we care. It is reduced. All right, so at this point, you're going to stop and complete the rest of your problems if you haven't already done so.